Maybe the Big Bang is an interesting event, but not the beginning of time. This reality might be one of many. String theory does have the capacity to describe the world as we know it. Principle is the idea that we could be visited by aliens a crazy idea? No, it's not crazy. If they're a billion years ahead of us, they're not building spaceships and coming to planet Earth because they don't care about us. Maybe the particles do have some kind of version of consciousness, some kind of proto-consciousness, a little bit of consciousness in the electron, in the quark, in the protons. Where does it come from?
What happened before the Big Bang?
No one knows what happened before the Big Bang. No one even knows if the concept of before is relevant when you apply it to the Big Bang. I mean, before obviously is relevant to what was I doing before I got here today, or what was I doing before the election, a couple weeks ago. All those notions of before make sense. But the Big Bang may be the moment where time itself began. And if that's the case, to talk about before the Big Bang would be to talk about a time when there was no time. And so it would be an incoherent notion. That's one possibility. The other possibility is, sure, maybe the Big Bang is an interesting event, but not the beginning of time, not the beginning of everything. Maybe the Big Bang is an interesting realm in which the universe swelled rapidly. That's what we mean by the Big Bang. But maybe the universe existed before that. Maybe there were other Big Bangs that happened before that. Maybe there's a whole prehistory leading up to the event that we call the Big Bang. As of today, nobody knows which or if any of these perspectives is correct. In our theories, mathematical theories, we always assume that there is time from the get-go. We don't even know how to formulate physical laws without assuming that time exists. So our mathematics gives us no insight into whether there is an origin to time or whether there might even be a realm where there is no time, there is no space, and only when the ingredients in that realm that we can't fully describe, when they arrange themselves correctly, then space and time as we know them emerge. We don't know if that's a sensible way of thinking about reality, but it certainly is a compelling one to imagine that as a possibility. Time could certainly be a human construct. Time could be something that we impose on the external world because it allows us to organize events. And when we can organize events, we can find coherence, we can find patterns, we can describe it all mathematically. But sure, can I imagine that we encounter some alien civilization in the far future and their conception of reality doesn't involve time at all, or maybe as fundamentally as our conception does, that they organize events according to a completely different framework that does not involve moment after moment after moment, that their experience is not felt as moment after moment after moment as our experience is? Can I imagine that? Yeah, I can.
Did universe begin from something small like a pin?
Sure, in the conventional approach to the Big Bang, which often goes under the name of inflationary cosmology, we imagine that there was a little tiny pea-like sized part of space that was filled with a certain kind of cosmic fuel. It's called the inflaton field. Name doesn't matter, but this fuel gives rise to powerful, repulsive gravity. That's a weird idea. We are used to gravity that's attractive. You drop something, it falls to the earth because the earth and the object attract one another. We have never directly experienced repulsive gravity, but Einstein's equations from general relativity say that it is real, that it does exist. And so imagine you have a little pea-like shape that's filled with this fuel that gives rise to repulsive gravity, causing it to rapidly swell, to blow apart. That's what we think may have been the Big Bang. And so yes, everything would have started from an incredibly small but dense, highly energetic starting point that gave rise to the Big Bang.
Creating cosmic web?
Cosmic web in terms of the galactic structures in the universe? Absolutely. So we can use the inflationary theory together with our understanding of the electromagnetic force and the nuclear forces, we can use powerful computers to simulate what the universe will look like after this rapid swelling. And we understand the formation of stars and galaxies, not in every detail by any means, but we can understand the processes well enough to get a sense of what the universe should look like on its largest of scales. And amazingly, while we don't have all the details, what our computers predict is pretty close to what we see. And that's an amazing achievement.
Cosmological landscape change your life?
Well, all of these ideas have changed my life because my perspective is guided by my understanding of reality. And so as I learned quantum mechanics, my sense of reality began to shift. And so and my engagement with the world began to shift. When I learned the general theory of relativity, the same thing happened. These were wondrous educational moments for me. It wasn't just learning about warps and curves in the fabric of space. I felt like I knew the universe better. I understood it better. I could engage with it more richly. And sure, these more speculative ideas that there might be other universes out there, does that change my view? It enriches it as a real possibility that this reality might be one of many. How could knowledge of these ideas not then back react on your own view of who you are and how you fit in? It does.
Infinity universes, do you believe that it could exist?
I think the possibility of infinite universes is an idea worth having in your toolkit because it naturally emerges from a variety of ideas, from the inflationary theory to the many worlds interpretation of quantum mechanics. So it may be true. And if it is true, it completely changes the landscape of reality. And so for me to sit here and imagine there might be a copy of me out there in the cosmos.
Somewhere there, infinity copy of us.
If the universe is infinitely big, then you can pretty much prove mathematically that there'd be infinite copies of us out there, one after another, sometimes having exactly the same conversations, sometimes having slightly different conversations. That's a crazy idea.
But is it the idea or theory, real theory? Can we talk about it seriously under physics?
You can absolutely talk about this idea seriously if you're willing to make an assumption. And that assumption, you should realize, could be wrong. The assumption is, does space go on infinitely far? Or could it be that you go out sufficiently distant and you maybe circle back to your starting point, as would happen on the surface of the Earth? We don't know the answer, but under the assumption that space goes on infinitely far, you can argue convincingly with mathematics that there would be copies of us out there.
Infinity universes can be connected with our universe.
Connections between the different universes depends on the flavor of the multiverse that you look at. If you're thinking about an infinitely large universe, then yeah, in principle, you could start here, and in principle, you could pass through those universes if you had enough longevity and if you could travel fast enough. But there are other versions of infinite universes, such as that from quantum mechanics, where you really couldn't jump from one universe to another. That's not the way that version of the multiverse emerges. So it's completely dependent on the flavor of multiverse that you're interested in.
Is UFO visiting us?
Look, in principle, is the idea that we could be visited by aliens a crazy idea? No, it's not crazy. It's conceivable. I allow it as a logical possibility. But it's so far-fetched that it's not an idea that I at all take seriously. And if you're interested, I could tell you why, right? Which is simply this. Planet Earth, it took a few billion years for life to really take hold and ultimately for intelligent life to emerge. So the time scale from the birth of a planet to the emergence of life is on the order of billions of years, which means out there in the cosmos, if there are other planets with living systems, likely they will be either a billion years behind us or a billion years ahead of us. It would take an unlikely coincidence for them to be at roughly the same evolutionary stage that we are right now. If they're a billion years behind us, they're not building spaceships and visiting planet Earth. If they're a billion years ahead of us, they're not building spaceships and coming to planet Earth because they don't care about us, because we are these puny little ants.
We are the pin.
Yes, we're nothing compared to them. They have no interest in us whatsoever. And moreover, let's say that they're doing some strange anthropological, archaeological mission to see what's happening on planet Earth, just as a science experiment for some advanced student in a school that's a billion years ahead of us. You really think they're going to have to evade our detection mechanisms? They won't be smart enough to be able to shield themselves if they want to be shielded. We're going to catch sight of them with our rudimentary detection equipment. That's so ludicrous. So this idea that they would be floating around and then trying to evade our detection is so anthropomorphic. It's so 21st century, even 20th century anthropomorphic that it's kind of ridiculous. I think many people have a desire for there to be more to reality than the surface experience. And I think this comes from a certain sense of longing, a longing to have a greater impact on the universe, to have a greater connection to the universe, to have lives that matter more than they might seem to on the surface. And this drives people to take seriously certain weird phenomenon because it fits that urge. It fits that sense that we're chosen or we are privy to this deep truth that others have missed. It makes us important if that's true. My own feeling is if only these people understood science a little bit better, quantum mechanics itself can provide that. Quantum mechanics
is enough magical.
It's so magical. It's so bizarre. It's so strange that even Albert Einstein never fully accepted the things about the world that we now are pretty certain are true after 50 more years of experimental study. And so it feels to me a lost opportunity to reach people with the real ideas about the external world, because they're stranger than the ideas about channeling. They're stranger than the ideas about aliens visiting us. And to me, they're more intriguing and more gratifying because there's experimental evidence behind it. And that's, I think, the real lost opportunity.
Should we seriously talk with the people?
Do I talk?
Yeah, seriously.
I do my best to talk seriously with people about these ideas through books, through television shows, through this kind of a conversation. That's why I'm here right now. And so the hope is that people can be drawn in by the weird, wonderful reality that science has revealed, as opposed to the made-up, imaginative machinations of an overworked mind that's searching for something to latch onto to give their life meaning.
String theory.
I agree that string theory is a beautiful mathematical structure. I agree that there is zero experimental or observational data establishing that string theory is the correct theory of the universe. So what do you do?
And it doesn't work when we have more than 11 dimensions.
And the theory absolutely requires that the fabric of space be far more subtle and rich than Einstein himself or Newton would have thought. The possibility of extra dimensions is a natural consequence of string theory. All of this is true. Nevertheless, string theory does have the capacity to describe the world as we know it. Is it the right theory? We don't know. And so as the most promising approach that we have yet found for putting Einstein's ideas of gravity together with the laws of quantum physics, a union that has to happen. You can't have physics without general relativity and quantum mechanics playing well together. As string theory is still the most promising approach, of course we should pursue it mathematically, vigorously, seeking to extract some observation or experiment that maybe one day we can carry out. But as I said in the Washington Post article, if somebody comes along tomorrow and shows that there's a mathematical flaw in string theory, we should abandon it. This has never happened. If tomorrow somebody should come along and say, look at this new idea. that we can put general relativity and quantum mechanics together and it's immediately close to the world and we can test it. And let's go, of course I'd be excited and I would jump at that possibility as a new direction to pursue. So I'm not sitting here dogmatically saying string theory. No, not at all. I'm saying truth. Let's try to find things that take us closer to truth. At the moment, that is string theory in terms of putting the laws of physics into a unified framework. But is it possible that we'll have something else? 3 years, 5 years, 100 years? That string theory will be relegated to the dustbin of science? Is that possible? Of course it's possible.
Maybe Twister's theory will replace string theory.
Look, Roger Penrose, so he did a remarkable job in developing the twistor idea. And there's beautiful mathematics within twistor theory. And in fact, there are subtle ways that the twistor idea has been in dialogue with string theory. It's not as though these ideas are at opposite ends of some kind of theory spectrum. And so, yes, is it possible that there's some deep truth in Roger's approach? Yes. Is it possible that there's some deep truth in the string theoretic approach? Yes. How will we figure it out? Continue to work, to develop the equations, develop the mathematics, extract whatever insight we can into the theories. That's the only way to answer those deep questions.
Do you believe that we'll ever find the answer what connect quantum world and classical reality?
Yeah, I mean, we're still struggling, even, and this is an important lesson, we're still now struggling 100 years after quantum mechanics was written down by Heisenberg and Schrödinger. This is 1925 and 1926. 100 years later, we can use the equations to make predictions that are borne out by experiment. We can use the equations to engineer things like integrated circuits, making everything from, cell phones to laptop computers that have revolutionized life on this planet. And yet, even with those successes, there are deep questions within quantum mechanics that we've yet to resolve. And the biggest one is, how do you go from the quantum description of a reality that is described as a fuzzy haze of probabilities, which is the language of quantum physics, how do you go from that to the definite reality that we all experience every moment of our lives? What's the transition from the quantum to the
How
classical?
matter is transformed from the quantum world to classical reality.
Yes, that's the deep question. Now, there are many physicists who think that's a non-question. Niels Bohr, founder of quantum mechanics, thought that was a non-question. He said, you're thinking about things wrong. You're stuck in an old mindset. The new mindset, Bohr said, is you have a realm of classical equipment, and that's the stuff that we see in laboratories, and you always use the classical language to describe those things. And then when you're talking about the molecules and the atoms and particles, you use the quantum language only down there. The problem with that perspective is that the equipment is made of the very same ingredients that you use quantum mechanics to describe. It's made of the electrons and the protons and the neutrons. And so if quantum mechanics describes the ingredients in the equipment, then it must describe the equipment, which is nothing but a conglomeration of the ingredients. And it's that step that Bohr would somehow resist, and it's that step that we are still struggling to understand.
Quantum mechanics is for you local or non-local?
Quantum mechanics, as far as we can tell, is non-local. And this is one of the deep insights that came from the work of John Bell, working in the 1960s, a name that most people have never heard of. Everybody knows
But
Einstein.
should.
They should, because it was John Bell, almost as a hobby. He was working at CERN, particle accelerator, was working on other things, but in his spare time liked to think about the foundations of quantum mechanics. And in his work, he was able to reveal a test to determine whether or not certain ideas that Einstein had, that the universe was local, what you do here only affects things here, and that it was real, that particles always have definite features. He came up with a test of Einstein's view. Nobody thought you could test Einstein's view. It was just metaphysics, ideas. Go away, Einstein. You're just thinking philosophy. We're physicists, which is basically what people said toward the latter decades of Einstein's life. But John Bell said, no, this is not just philosophy, this is physics. We can actually test whether these things Einstein was saying are true. And when the tests were done, they, to most people's satisfaction, revealed that Einstein's view that the universe was local, that was not true, that the universe is non-local. In a sense, what you do here can, in a very specific quantum way, be connected to something that happens over there.
Don't you think that we were not programmed to understand the universe, but just only to survive?
Absolutely. Our brains, like the rest of our bodies, like every species on planet Earth, is here because it survived, and it survived because survival of the fittest. We evolve over time to have the capacities that allow us to get the next meal, or to find shelter, or to avoid a predator. That's why we are here. And our brains do that by finding patterns in the external world. Because if you can see a pattern out there, you've got a leg up in the battle for survival. If you can maybe predict with some certainty what's going to happen next while your competitor can't, you're more likely to win, to survive. That's why we're here.
So as a physicist, you are fighting with nature.
I wouldn't say that we're fighting with nature. What I would say is, once our brains gained the capacity to recognize patterns that aided survival, that capacity then went overboard. It evolved to a place where it could spot patterns that are irrelevant to survival. And then as we began to conquer the natural world, where we didn't have to spend all our time gathering fruit and nuts or throwing a spear at an antelope, when we had enough time, we could use that pattern recognition capacity to start to think about things like the pattern of the motion of the planets, the pattern of the motion of objects that we throw, or even then the pattern of the motion of the electron in the atom, or the pattern of the energy that comes out of the accretion disk around a black hole. These are just extensions of our capacity to recognize patterns that were at first in the service of survival, but now we have not fought against nature. We've leveraged that capacity to go even further.
Can molecules be involved in the natural selection process?
I think molecular Darwinism, as we often call it, is a vital part of how the world has evolved. Many of us, when we learn about evolution by natural selection in school, at least here in the United States, it's always at the level of living systems. Living systems, they have progeny. The progeny won't have exactly the same characteristics as their parents. And those new characteristics which aid in survival, they will spread widely because the bearer of those characteristics will have a better chance of living to the age of reproduction. Now, that's only at the level of living systems. There's a version of that that happens at the level of molecules. Molecules can have children, so to speak. They can have progeny. Molecules can learn the trick of replication. And once a molecule can make a copy of itself, we recognize that no copying process is ever perfect. There will always be mutations, slightly different molecules, and those mutations that aid in the process of making more replicants, they will spread widely. So the molecular demographics will become dominated by those molecules that can reproduce swifter, faster, with greater economy and greater stability. So in that sense, molecules themselves fight other molecules, chemical combat that ultimately yields refined molecules, and those are the molecules that ultimately make up living systems.
What's about the entropy in the universe? Can the actions, the molecules increase entropy in the universe?
Yeah, every physical process, by and large, except for very unlikely events, results in an increase in entropy, for the basic reason that entropy is simply a measure of the number of ways that a given system can be realized. And if there are more ways that a system can be realized, it's more likely that that configuration will come to be. And so over time, entropy increases at every level, at the level of molecules, at the level of living systems, at the level of the universe. Now, it may not always seem that way, because we can do things that seem to decrease the amount of entropy, decrease the amount of disorder. We can order a system using our brains and using our volitional capacities. But if you take into account the amount of entropy that our bodies create in the process of yielding that ordered system, then the overall entropy always increases over time.
Entropy and evolution of the universe are what mainly determine operations in the universe, all operations in the universe.
Yeah, when I think about the dominant forces at work guiding the cosmic evolution, I do think of it in terms of entropy and evolution. Entropy is this drive toward ever greater disorder. Evolution is this drive toward ever greater refined systems that are able to replicate with greater capacity. And so they kind of seem like at opposite ends of the spectrum. Entropy driving us toward disorder, evolution in a sense driving us toward order. Now, in a sense therefore, these two forces, they kind of battle against each other during the unfolding of the cosmos. Ultimately, entropy wins. If you look at the far future of the universe as we can understand it using our mathematical equations that describe the laws of physics, it's pretty clear that every ordered system in the universe ultimately decays, ultimately falls apart. Yes.
Every single system?
Every single system. So stars ultimately run out of nuclear fuel and either explode or turn to a simmering, smoldering mass. They lose that beautiful ordered structure that gives rise to heat and light that comes out of a star during its living system. Even black holes. Ultimately, Stephen Hawking taught us that
mystery of black hole.
A big mystery of black holes, but there's some aspects that we understand well. And Stephen Hawking taught us that black holes emit radiation slowly, but they emit radiation over time. So their configuration ultimately gives rise to a bath of particles, disordered particles that waft through the universe. So every system that may embody order at a given cosmological epoch ultimately disintegrates, falls apart, gives rise to a disorderly end product.
All we know about the human consciousness is that I have consciousness, you have consciousness, this director chair does not. That's only one thing we know about the consciousness.
Well, there would be people who would debate even the statement that the chair doesn't have consciousness. I agree. I don't think that it does. But when we try to understand the basis of consciousness, we run up against what's known as the hard problem. And the hard problem is simply that your brain and my brain and everybody's brain is made up of molecules and atoms in particular configurations. If the individual particles don't have inner worlds of subjective experience, conscious self-awareness, if the particles don't have that, how is it that by putting a lot of particles together, you do yield an inner world of sights and smells and emotions, this inner world that we all have playing out inside of our heads? Where does it come from? Some have suggested that the starting point of that puzzle is incorrect. Maybe the particles do have some kind of version of consciousness, some kind of proto-consciousness, a little bit of consciousness in the electron, in the quark, in the protons, and maybe that little bit inside of things. And therefore, this chair, from this perspective, would embody a certain rudimentary kind of consciousness because the ingredients themselves would embody that. This is not an approach that has convinced me, but I understand why people introduce this idea, because I cannot answer the question of how can a collection of mindless particles gain mindfulness? How does that happen? Nobody can answer that question. My intuition tells me that consciousness somehow emerges, an emergent phenomenon when you have particles, molecules, atoms in a sufficiently coherent arrangement. But if you ask me, how does that happen? I remain at a loss because I don't know and nobody knows the mechanism by which consciousness emerges from orderly structures. My guess is that one day we will understand how that happens. But there are some who say that's too optimistic a viewpoint. You can't get consciousness from something that's not conscious. You can't take a bunch of particles, each of which has no consciousness whatsoever, put them together and have consciousness emerge. Some people feel that very, very strongly.
Maybe consciousness is born in the quantum phenomenon.
Yeah, I have no doubt that quantum physics in some way, shape, or form is important to consciousness because quantum physics is important to the way physical things in our universe behave. And those physical things include, of course, the particles that make up the atom, and the atoms that make up the molecules, and the molecules that make up the cells, and the cells that make up the brain, which somehow has conscious awareness. So quantum mechanics has to be, at some level, part of the story. But I do not think, or at least I do not see any evidence, that the structure of quantum mechanics per se necessarily yields consciousness. To me, it's more. It's the laws of physics together with the orderly structures that are the substrate within which consciousness takes place. And so I don't see a direct route from quantum mechanics to consciousness, at least not in the way that I think Roger has imagined it.
I need to ask you about free will. Do you understand the difference between free will and consciousness? Professor Sapolsky deeply believed that there is no free will. We are biological machines. Everything is determined by the cells, by molecules, by atoms. Do you feel the difference between consciousness and will?
Yes. So the question of free will hinges on your perspective regarding consciousness. If you believe, as I do, but I do not have proof, but if you believe that consciousness is ultimately reducible to physical processes, biological processes, chemical processes, if that's all that consciousness is, then you pretty inviolably come to the conclusion that there is no free will. Why is there no free will?
It's so sad.
It is sad in a way, but in a way it's actually, I think, quite liberating. But again, the argument is, if the ingredients from which consciousness emerges, the particles, the molecules, the atoms, if they are governed by physical law, you and I and nobody else has the ability to intercede in the lawful progression, the lawful behavior of those particles. So when you, in your mind, make a decision or have a thought, ultimately, if that conscious awareness is nothing but molecules moving one way or another, you can't control those motions, and therefore you can't control what's happening inside your head.
You mean that we are not determined to answer the question what consciousness is?
Well, it depends what you mean by determined. So there's two kinds of determination within physics, and they've been used in different periods of time. In the old classical physics, prior to quantum physics, the idea of having a determined system is you tell me the state of the system right now, the positions and the velocities of all the particles, and I'll simply use the laws of physics to predict what that system will be like 5 minutes later, or an hour later, or a year later. The initial conditions and the laws of physics determine how things will be, period, end of story. That's classical physics. Quantum physics, which has supplanted classical physics, says something a little bit differently. It says, tell me how things are now as best as possible, describe the state of the system, and I will use the laws of quantum physics to predict the likelihood that things will be one way or another way still in the future. You can only predict probabilities, but those probabilities are just as determined in quantum physics as the outputs were determined in classical physics. It's just you're determining something else. So to my mind, you can sort of have your cake and eat it. People worry. if I don't have free will, does that mean you can predict what I'm going to say in 2 seconds? Answer is actually no. The best you could do is predict the probability that I'd say one thing or another still. And so there's an open quality to the future in quantum physics that you would not have in classical physics. So yes, I do not believe that I have free will, but I also understand that you can't use the laws of physics to predict with 100% certainty what I will do, because you can only predict probabilities of one or another outcome.
Human thoughts itself, it's a lifetime limitation in the universe. What does it mean?
Well, if you believe, as I do, that thoughts are physical processes, that there's no structure beyond the physical that somehow is the place where thoughts originate and take place. I'm not going to go to any of those ideas. I don't even know what they mean. So if I think of thought as a physical process, every physical process results in an increase in entropy.
Energy.
Ooh, a little bit different. Every thought and every physical process requires energy. Yeah. But the output of the process through which that energy is used is to increase entropy. The amount of energy can stay fixed, but the energy degrades over time. And that degraded energy is what we mean by disorder or entropy. The reason why this is important is the following. Right now, as we're talking, I am producing a lot of entropy, hopefully not in the ideas that I'm communicating, but rather because I am giving off heat. I am emitting waste to the environment. And if you had the right instrument, you'd see the infrared light coming off of my head. That is turning energy into less useful energy. That infrared radiation is hard to make use of. That is what we mean by entropy. In this room is very good at being able to absorb the heat, the waste, the entropy I'm producing. But in the far future, as the temperature of the universe comes down, you can argue convincingly with mathematics that there will come a point when the universe can't absorb the entropy, it can't absorb the heat that thought itself creates. At that point, if a thinking being thinks one more thought, they will burn up in the entropic waste produced by the process of thought itself. They will die. There will be no further capacity for thought to take place.
Human beings determine entropy.
Human beings create entropy, as does every other living system, as does every other physical process in the universe.
How do you define the truth? What truth is for you?
Well, I think truth comes in a number of varieties. There is something that I like to think of as objective truth, which speaks to the qualities of the external world that we attempt to describe using mathematics, be it the general theory of relativity, be it quantum mechanics. These are mathematical approaches to try to get at the truth of the physical processes that take place in the universe that have been holding sway since the Big Bang, giving rise to stars and galaxies and planets, and on this planet living systems. There's also another variety of truth, which is a more internal, subjective truth. These are the truths that every human being holds. Truth. Yes, these are the truths that every human being holds within their mind. There are things that deeply matter to me, my family, my parents, the things that I spend my time on, my perspective on the political situation. These are vital truths to me as a human being, but they're not objective. Not everybody will agree that these are fundamental truths of the universe. They're things that matter to me as an individual human. Often we get these mixed up. Things that people think of as objective truths oftentimes are just subjective truths that matter to them. And having a clear understanding of the truths that are external and out there versus the ones that are internal is a vital distinction to make.
You think that we can discover mathematical idea?
Yeah, I would use a slightly different word. I would say we invent mathematical ideas. We don't discover them. To discover them would suggest that they're out there waiting to be found. You just need to unearth them. Somebody else created them, or the universe created them, and they're out there. And I don't think there could be any possibility that this is true. Mathematics is a language that we humans developed in order to find a very quantitative and accurate approach to embodying the patterns that we see in the external world. We invent mathematics. The theorems and the proofs that mathematicians proudly publish in papers and journals around the world, it's not that they don't have value, but they are truths that emerge within the language of mathematics that we invent. There is no meaning to these statements, to these theorems, to these proofs without the language of mathematics itself, and we invent that language. And so take the Pythagorean theorem, a squared plus b squared equals c squared. We invent the idea of a triangle. There's no real triangle in the external world. We invent the idea of a line. We invent the idea of a right angle. There's no real right angle in the external. They're close to right angles, but we invent the ideas and then we find interesting features about the concepts that we invent. Now, most mathematicians recoil at this idea because somehow the validity and value of what they're doing for many rests upon finding external truths, things that are out there that will always be true. And my answer to that is the Pythagorean theorem, a squared plus b squared plus c squared, it only has meaning when it's resonant inside of a head that can understand it. And in the far future, when there are no thinking structures left, when there's nobody able to think anything at all, the Pythagorean theorem will not exist. Where will it be if it's not resonating inside of a mind that can understand it? To say that math is out there, independent of us, has as little validity as saying that there is a deity out there, independent of us doing things. And if you're willing to go in that direction, then I believe you're undercutting the logical structure of the insights that we're able to gain about who we are and what we do.
Can physics allow for God evidence?
Of course, physics can allow for God. It could be that there is a God. I can't prove that there isn't a God, just like I can't prove that mathematics isn't out there. The best that anyone can do is marshal the most convincing argument based upon things that we know about, things that we've seen, that we've observed, the data that we have. There is no data. There is no evidence that I've ever seen that gives me any confidence that the idea of a God is real. That is not proof that God is not real. It's merely giving you insight into my thinking and the thinking of many others as well as to why this might not be true. But could it be that there's a God out there and carefully has arranged things so that there won't be any evidence, so that the God has hidden their role in the world and just maybe given clues that only the world's priests and imams and rabbis can find? Maybe, but I don't find that a plausible way of looking at the world.
Religious people like you.
Do religious people like me? I've found that I can have conversations with anyone and we can leave that conversation feeling good, because my approach to the world is not to undercut someone's position, but rather to hear them and to see the degree to which their perspective can be integrated into my own. So unlike some of my colleagues who say religion should be wiped off the face of the earth, that it's the most egregious and awful result of civilization, I don't feel that way at all. I find religion to be a beautiful structure that speaks to who we are and what matters to us and the ideals that we have. Of course, religion can be used for bad, just the way nuclear understanding can be used for bad or good. And so religion as a tool can have some very negative consequences. But viewed in the most positive light, religion's a beautiful, really spectacular invention of the human mind. The thing that we're most terrified about as human beings is our mortality. How wonderful to invent a structure whereby our death is not the end of our existence. Our death is merely a step within a much larger story. And so that's a very beautiful way of quelling the existential anxiety that comes with mortality awareness. That, to me, is an internal truth for those who believe it. It is not an objective external truth, but internal truths matter, they're valuable.
There is a William James book from 1902. Do you know that?
Yes, I do.
Why
Varieties of religious experience.
Yeah, why we need religion, why we need to be under control, superpower.
Yeah. Absolutely. William James is a hero of mine because here you have a scientist trying to understand the human condition through the lens of rational thought and rational gathering of data and rational evaluation of people's experiences. And William James came out of that experience, understanding the worldwide experience of religion and religious phenomenon from very different perspectives, and came with a very beautiful perspective on how religion meets certain needs that we have, how religion serves certain purposes for we as human beings crawling around the surface of a nondescript rock, orbiting around a nondescript star in the outskirts of an ordinary galaxy. Who wouldn't suffer from anxiety? Who wouldn't suffer for terror and fear to be thrust into that reality? And if religion can help quell those fears, if religion can tell a larger story that can make an individual feel that their life matters in the grander scheme of things, then yeah, that's a powerful structure and it's a powerful role for this idea that we have invented called religion.
If you could find just only one answer for just only one question about the reality, what it would be?
I would like to understand the nature of time. Is time something that we impose from our minds, or is it somehow intrinsic to the structure of reality? That would be one big one, but if you let me even dream even bigger, the biggest question of all is, why is there something rather than nothing? Not empty space, nothing, but why is there anything at all? Logically, you could imagine the absence of space and time and matter and energy and everything. What brought existence into being?
But outside the universe, there is nothing.
We don't know if there's even a notion of outside the universe.
The deepest unresolved question at the heart of quantum mechanics: how does the probability quantum haze transition in the defined reality of everyday experience? Could you answer for that question?
I don't know an answer to that question. That is the question that we were discussing before. What is the means by which a description of the world in terms of probabilities turns into an experience of the world that is absolutely definite? How does that transition take place? We've made a lot of headway with ideas of so-called decoherence and things of that sort. But in terms of truly answering the so-called quantum measurement problem, nobody knows the answer.
What are you doing now? Tell me something about your actual research.
Yeah, so right now with a number of colleagues, we've been studying the possibility that the extra dimensions might have yet weirder properties.
Your mind is dimensional. You're still thinking about dimensions.
Yeah, we're certainly still thinking about extra dimensions. The possibility that the extra dimensions might allow you to circumnavigate them. Maybe the extra dimensions is a large circle, a shape that you can fully transverse. And the reason this turns out to be interesting, we found that in these possible scenarios, you could send a signal from here to someplace far away, and it could get there faster than the speed of light. Faster than the speed of light.
It's impossible.
That's what most people would say, and that's what we thought too. But it turns out if you send the signal...
Einstein said that it's impossible.
Yeah, so
the speed faster than light doesn't exist.
So we're completely compatible with Einstein because locally, the speed of the signal is always equal to light speed. But if you have an extra dimension, there's two trajectories to go from here to here. There's the direct one from here to here, but there's the indirect one where you spiral around the extra dimension and get there. You would think that spiraling around would take you longer, but it doesn't. Even going at light speed, you can beat the signal that goes from here to there directly, effectively sending a signal from here to there at faster than the speed of light. Everything I do is theoretical. Everything I do is mathematical. And so yes, this is under the assumption that there's an extra dimension in the shape of, say, a circle. It's also making the assumption that we live on a so-called membrane in string theory that's moving along this extra dimension. There's a whole set of assumptions, but remarkably, with those assumptions, you can send a signal from here to there at faster than the speed of light.
Finalizing our meeting, I need to ask you about AI. Do you believe that we can ever achieve something called AGI, strong AI, superhumans AI?
Without a doubt, I believe that. There's no obstacle fundamentally to the capacities of these artificially intelligent systems. Look, I don't think there's anything special about the biological brain that gives rise to consciousness and intelligence. I think that if you were to engineer a version of what's inside of our heads in silicon, that in principle it could think and feel and be intelligent, and there'd be nothing in principle stopping you from cramming information and capacity and chips and circuits that will allow that artificial structure to operate at a level that's beyond our capacity. So do I think that we will get there? I do, and I don't think it's far away either.
AI, it's for you something more than just only statistical?
Well, look, the approach that the large language models have been following is certainly one way. It is a statistical approach based on large data sets. But that's not the only way that researchers have been and will continue to try to achieve artificial general intelligence. You could couple those statistics with some model of the external world, with some understanding of the fundamental laws of physics, some understanding of what we have already learned in a very concrete framework. That additional structure by itself, in principle, could allow the probabilities to get you to results that are more relevant, more insightful. And so that would be a more intelligent system compared to one that's based purely on the statistics. And that's merely one approach. You've got some of the most creative thinkers in the world that are researching ways to make these systems ever better. And I don't see any limit to what it is that they can achieve.
A lot of people think that even our language, it's not enough to describe what we created, because AI, the word AI, it's not artificial, it's real.
Yeah.
We have also not one artificial intelligence. We have archipelago of islands that, of course, we integrate each other, but still there is not one continent.
Yes, I fully agree. The whole notion that intelligence can be organic or artificial is itself an artificial distinction, right? You have systems that can take in information and produce useful information as output. And whether that system happened to emerge through the ordinary biological process of a living system maturing or through some system that we build, well, it doesn't really matter. In the end of the day, it determines on input versus output. And if you can build some system that is intelligent, it is a new kind of intelligence, not necessarily an artificial version of intelligence.
I have two final questions to you. The first one is about your own Congress, World Science Congress. Why you founded that?
World Science Festival.
Yeah, why Science Festival?
Well, way back when we began the World Science Festival, we recognized an opportunity to get people excited about forefront ideas in physics, in mathematics, in computer science, in cosmology, in chemistry, and biology. And so we said, why don't we create a gathering place where we'll bring the world's leading scientists to be in direct conversation with the general public. And so this idea caught on, and at our first gathering we had 120,000 people come to the events. And so we recognized that we had really tapped into something that mattered to people. And so we've been pursuing it ever since.
Who today inspired you the most? Who was your master? Your father a musician? Or
Yeah, my father had a profound impact on me.
And today?
Well, my dad was a musician and a composer who did not have even a high school education, but was deeply interested in the world. And he was seeing it from the perspective of art, perspective of music. And that inspired me that there are so many different ways to understand reality, and each of them gives you new insights. And so that's why I don't spend my time just doing physics per se. And I think my father's influence is a big part of that. I want to understand the various ways of seeing into the workings of the world, be it from art, science, literature, music. All of these provide a more rich engagement with reality.
Thank you for your time.
My pleasure. Thank you.